Alright, in this video I'm going to make a tensile test specimen, something that's kind of familiar to everybody. I'm going to use Hypermesh, and I'm going to end up using millimeter units. My tensile specimen, however, is designed in English standard units and is about 6 inches tall. So we'll go through and convert these things into millimeter units and identify some key points along this specimen geometry. We're going to create a plane of two-dimensional elements. We're going to rotate that plane of two-dimensional elements in Hypermesh, and then we're going to create a 3D solid. Now the purpose of this mesh, I'm going to eventually use it in Abacus, and I want to illustrate the effect of not having an extensometer and trying to calculate the strain based on the gauge length section, and we'll see what some of the pitfalls are in that. So basically the thing is 6 inches tall. There's a 2-inch flat central portion. My sketch isn't real good, but we'll be more precise on the Hypermesh. I want to be able to show a 1-inch extensometer attachment point on it, and the radii curvature are going to be 1/2 inch on this particular specimen. And then the balance of the specimen is going to be the grip dimension. So we're just going to create the nodes and elements, and then later on we'll import those into Abacus, probably in a different video. Now before we get into Hypermesh, one of the things that you might have a problem with in Hypermesh 2019, maybe other versions too as well, I'm not sure, is that in some cases your nodes and your temporary nodes that you create do not appear. So you may want to set a system variable for that. So let me minimize this window and we'll take a look at those settings. If you can't see the yellow nodes that I'm going to create, you're probably going to need a system variable. You get that into the system from the system's properties window in Windows, and you go in here and you create a variable name. It says HW_use_OpenCL, and the variable value is 0. You set that environment, and then you'll be able to see these nodes that I'm going to display here in just a minute. Now I've gone and practiced this a little bit. This will be what our specimen will end up looking like in the end. And the way I'm going to do this is something, a way that you may or may not want to do. It just depends on what your familiarity is with Hypermesh. And the other thing that we're going to get that you may or may not want to do is around here we're going to end up with some wedge elements, and these may or may not be what you want. For my purposes, these wedges will be fine. If you're doing something more sophisticated, you may want to have all kind of brick elements like I have on the exterior of this. Alright, so let me make a new model here, and then we'll kind of get into it. Before we do that though, I want to lay out the key points in my model. And again, there's more than one way to do this kind of thing. I'm going to model the entire plane from the center line. So everything to the right of that line is a plane, then I'm going to revolve that to get my 3-dimensional specimen. So I will need to identify some key points. I'm going to try to draw this bigger. So here's the center line. There's the large grip section. There's going to be a central section, and then these grip sections, and this is really exaggerated, but then there's going to be some sort of radius of curvature, and then I'm going to chop this off and section this up. I want to identify my key points, and I want to identify where the exact kind of middle point of my specimen is going to be at, and then a section that's a 1/2 inch above and below that section, and then identify all these other key points that I have in here. We're going to learn about line splitting and creating nodes on lines in Hypermesh. So let me calculate these all up, and then we'll make a list and we can put them into Hypermesh. Alright, and so I've identified a bunch of key points on here in millimeter units, and I'll punch these into Hypermesh in just a moment. There are 2 points that I don't know the position of, and that's this one here and this one here. That'll be where that radius ends, but we'll show you how to figure those out. I also want to emphasize again that there are many ways to do this. You could make a CAD drawing or do something like that and import that into Hypermesh. You can do half of what I have drawn here and then do a reflection to the other half. But this is the approach that I'm going to take, and you kind of see how I manipulate things inside of Hypermesh. So with that, I'm going to bring up my Hypermesh. Again, this is 2019, and I'm going to take this over to the side so I have this to refer to. Alright, so I'm going to get in here and go to Geometry. You may not have, it didn't show up when I brought the screen up, but I selected Abacus Standard as my finite element code. And I'll go right into nodes. Okay, I'm going to put this in the XY plane, and I'll just use my 0, 0, 0 point as my kind of base. Okay, so there it is there. My specimen has a radius of a half of an inch, or excuse me, a diameter of half of an inch, and so that goes to a radius of a quarter of an inch, which in millimeters is 6.35 millimeters. So my next point is going to be 6.35, comma 0. Okay, so put it down here. Now I'm going to go up 2 inches, 50.8 millimeters. I don't see it, so I'm going to rescale it. Okay, now I'm going to go into the gauge radius. The gauge diameter is a quarter of an inch, so the gauge radius will be 3.175. Let me just check that. Yep, that's 1/8 of an inch for the radius. It's 1/4 inch diameter. So we're going to go 3 point, let me get over here. We're going to go 3.175 and 50.8. I want to point just across from that as well, and so I also going to have 0, comma 50.8. Okay, I want to go up to the top. I'll do that next. .35, comma 152.4. .0, comma 152.4. 6.35 and 101.6. 0 and 101.6. And 3.175 and 101.6. The exact halfway up spot of my specimen, 3.175, 76.2, and we'll put a node on the axis at that same location. And then my other segments, other positions I want to make sure that they're precise on is 3.175 175 and 88.9. That would be the top knife edge of my extensometer. We'll put a node along the axis of that as well. And then down below that, we're going to have 0.63.5 and 3.175 and 63.5. Alright, so I do have a lot of nodes in here, but this is kind of what I want to do to make this geometry. Okay, I'm going to return on that. These are all my temp nodes. I'm going to come over here and create a component. And I'm just going to call this lines. And I want to pick a color that doesn't look like my element, so I'm going to pick, say, blue, for example. Alright, I'm going to get in here in lines. And I'm going to select connect linear nodes. Just going to go around here and make some lines. And if you notice, I'm doing each of these at a time. If you notice, I am not connecting this offset. We're going to smooth this with a radius of curvature in here. Alright, so those look like a good bit of lines in here. And I'm going to use a 1/2 inch radius of curvature. We'll see where we want the center of this to be. I think we're going to move the center out here about a 1/2 inch or so. Might not quite be a half, or what did I say, a 1/4 inch radius of curvature. I guess I did say 1/2 inch radius curvature. It might not be quite that, but we'll get something that looks nice. And it's not going to be an exact ASTM type specimen, but it's pretty close to what we have our machine shop create. Alright, so for the radii curvature, let me make a new component. And I'm going to put in another temp node that's at this level right here at 50.8 up. And let's make it 25.4 over. Okay, so it's kind of sitting out there in space. And I'm going to create an arc. So I'll get into the line panel, and I'm going to do this this one right here. Going to create it about the z-axis with a radius of 12.7 and an angle of 90. Let's see what that looks for us. Oops, need to select my center node. Okay, there we go. Okay, so it made that radius curvature there. We're going to return out of this panel, and we're going to rotate that and translate it. So we're going to rotate this red line about this base node with an angle of 90 degrees, and we're just going to hit this until it gets in the position we want. And that looks not quite what we want. We want it to transition from this line to this one, so we want something like that. Okay, now we want to mate this line with this blue line that's for the gauge section. So we're going to get in tools, and we're going to translate a line that we select in the x-axis direction, and the magnitude we're going to translate is 6.35 millimeters at a time. We'll see where that takes us. I'm going to translate minus. Okay, we have to go a little bit different than that. We're going to go 3.175 and hit translate minus. Okay, so now we've kind of lined that up with this one, and this will be our radius of curvature that we'll have. Again, it'll look good once it's in 3D. Okay, I'm going to return out of here, create a new component, Rad2. Let's make it a slightly different color, kind of orangey. Let's see, that doesn't show up real well. There, that looks a little better. We're going to organize a line that we select and put it in the destination component Rad2, and we're going to copy it. Okay, so now we made a copy of it. Now we're going to translate let's turn off radii, this one. We're going to turn that geometry off. We're going to translate the orange line up the y-axis, and let's see, let's translate it by multiples of 6.35. Okay, that's not in the right orientation that we want. So now we're going to reflect this line about the x-axis with this as the base node. Yep. Let's try the y-axis. Yep, that's what we want. Now we have that line there. Okay, so let's turn these lines back on. I'm going to go ahead and save this. And I'm going to work on these lines a little bit. Now I want to split this line at this intersection. I want to split this line at the same intersection as well. We're going to do these one at a time. We're going to go into geometry, line edit, split at line. Here's the line we want to split, and here's the cut line. Okay, now when I look at these, see how that is just highlighting white right there? We've got a split in this arc that we just made. We're going to reselect our line, and now we're going to use the arc as the cutting line, and we'll split that. Okay. I'll come up to the top, select the arc and the cut line and split, select this line, and now the arc is cut line and split. Now I want to find out where this node is located at. So what I'm going to do is I'm going to get into nodes, and I'm going to put nodes on a line. I'm going to put 3 nodes on the line. Now I have a node at that location. And we'll do the same for this one. Now that I know that there's a node here, I can go and calculate my distance from my origin node to here. So it is up 42.4 millimeters. So I'm going to create a node that's on the axis. It's at, I think I said 40.2 millimeters. Yep. Let me get my distance again. 42.4 millimeters. 42.4 millimeters. Okay. All right, now I'm going to do the same thing. I'm going to get the distance from my origin node to up here, and that is a distance in the y direction of 110. And I'm going to create a node in that area as well. All right, let's chop these lines up at the nodes. In line edit, now I'm going to split. We're going to try to split at a point. Let's see if that works for us. Okay, see how that split? Okay, so now we have all these different little line segments here. I guess I have to do this one. And I think we're in good shape to start creating our two-dimensional mesh. Now we can get rid of these lines that we don't need, but it won't hurt to leave them either. So I'm just going to leave them in here. I am going to save my file again under a new name. I like to have all these intermediate saves. And I'm going to get in here and start making components. Now that I have saved my file, I don't need these temp nodes. So I'm going to clear all of those temp nodes. Create a component. And now Abacus doesn't like it when you start a component name with a number, but these are going to be just for use inside of Hypermesh. So I'm going to call this 2D segment number 1, so just 2D1. I'm going to mesh this transition region here first. So I'm going to go into 2D, ruled, and I'm going to select some lines, this one and this one. And I'm going to mesh without a surface. You can use surfaces if you want, but I'm going to mesh without a surface. And it shows what it looks like there. Let's zoom in on that. Okay, that's what it looks like with 10 elements. That's probably, this doesn't look quite right to me. It should be, should have been cut right across from here. Maybe I keyed that in wrong again. Okay, let me see if I can fix that. I'm going to reject this. And let me load in my previous save. Might have got a wrong button here to look at. Okay, I see what happened. It didn't quite get this location right where I wanted it to be split. So what I'm going to do is I'm going to weld these together. I'm going to put another line right here, and then we'll split at a line. Okay, so I'm going to combine those two, and let me check up here as well. Just to be sure, I'm going to combine these. I'll get into my components. I'm going to right click and make current. Oops. I'm in the wrong, was in the wrong panel. So now I need to delete those. So Tool, let me find delete. Here it is, delete. Lines. Now let me get right into the right panel. And I'm still not in the right panel. Need to get into this one. Alright. So sometimes the practice helps and sometimes it doesn't. Okay, so now we're going to select this one and split at this line. And so now we're very precise. Alright, let's get down to the bottom. We're going to create a line. And then we're going to line edit, split this one at this cut line. And let's go ahead and add a line right here as well. It's not wanting to select that one. Let me see what's going on with that. Alright, so I just made it, extended it out here, and let's see if I can split it at this point. So I'm going to split this line at the cut line here. It's not recognizing that. Alright, let me fix this. I'll pause the video. Alright, so let's try this. We're going to split this line. Let's split it at the blue line for the cut line. Alright, well, it's being a little difficult for me, so I don't think we need that. Let's go ahead and try to create a mesh anyway. We're going to make a new component, 2D-1. Give it a color. Get into 2D, ruled, and we'll select these, mesh without a surface, and we have this here. Let's set all the edges to 10, and 10 may be too many for this side, so we're going to set these to 5. And so we'll mesh, and now we have kind of a transition there. Alright, let's get up in here. (2D2). Select the curved line and the straight line. Do the same thing, set them all to 10, and we'll set these edges to 5. Make a third component. Now we're going to set it to 5, so we have 5 here. 5 is probably not enough there, so maybe I don't think it's going to matter too much, but maybe 20. Let's see what that looks like. Okay, I think that looks pretty good. We're not going to be terribly interested in what goes on in the grip section. All right. Make another component. Selecting my lines. And now we're left with dealing with the central portion. And we're going to take these one segment at a time. I'd like a little bit more square elements, so I'm going to change these maybe to 10 on the edge. Maybe even finer than that. Maybe let's try 15. Okay, so that looks a little nicer. Taking this again a segment at a time. Alright, so it's got a funny little distortion here. We're going to need to fix that. Alright, so we're going to reject this. And it looks like that line didn't split quite where I wanted it to. So we're going to go through and we're going to do a process again where we get into lines and line edit and combine. And we're going to combine these two lines. We're going to create a new line. We'll make that component current. Okay, no problem selecting those. And now we're going to go and we're going to split this line at this cut line. Right, so that should clean that up a little bit. Alright, now if I can remember where we were at, let's see, we'll make a new component. Can't remember if we need to make a new one or not, but just go ahead and call it number 6. We're going to go 2D, ruled. We'll select these two lines, and then mesh without a surface. Set all those to 15, and we'll come back and set these two edges to 5. Alright. We have 2 segments left that we're going to do. Let me reselect these. And again, maybe we can do 15 on those edges. Let's see what that looks like. They look like they're about the same size. They should be, I think. And the last one. All right. So now I'm going to go ahead and save this since I've done all that work. clear all of our temp nodes. And we need to do a couple things at this point. I'm going to turn off all this geometry. It's kind of cluttering things up a little bit. Just left with our elements. I'm going to check for duplicate elements. So I'm going to get into Edges, Elements Displayed, Preview the Equivalents. Now I set my tolerance to 0.05 millimeters. Let's make sure we have a good value here. If you have a value that's too small, say 0.001, oh, they're pretty tight. Let's go 0.1. You could run into some trouble, and if things don't line up quite right, there may be some issues. But either one looks pretty good to me. It's always a good idea to kind of zoom in on some of these areas just to make sure that you're not over-selecting or under-selecting your nodes. Alright, so that's pretty good. We're going to equivalence. We'll get rid of that. And again, after the equivalence, I'm going to save it. Let's check our normals. We probably don't have to, since we're going to use this to create a three-dimensional mesh. But if we wanted to use axis-symmetric elements instead in Abacus, then we want to make sure all of our normals look like they're in good shape. So we're going to select Normals, Elements, Displayed Elements, and it looks like we have a region where we have normals that aren't matching up. So this is a color display. Let's do a vector display so we can see those. Alright, so you see how these are pointing out and these are pointing the other way? If we're going to use this as an axis-symmetric model, we need to have all of our normals pointing in the positive z direction. Okay. So the red ones down here are in the right orientation. So what I can do is I'm going to adjust these and then reverse these, and now they're all pointing in the correct direction. Save again. So we saw earlier it's kind of nice to have these so you don't have to recreate your work. Alright, so now I'm going to make a component. And call it specimen. And let's give it a nice color. We're going to go to 3D. We're going to spin the elements that are displayed with a base node at 0, 0. We're going to spin it about the y-axis, 360 degrees. We're going to make 36 elements on the spin. I always like to try to make some sort of multiple of 36, whether it's 18 or 72, just so I have a certain sector size and degrees that kind of makes sense. And we'll spin this around, and there we have our specimen. Alright, now inside of the specimen we need to check some things. We're going to turn off all the elements from the 2D geometry. Only leave the 3D elements showing. Yeah, there's what it looks like in a line view. We need to equivalence this. As this spins around, it creates two nodes on that final surface. So let's go to Edges. We're going to preview our equivalents. Whoops, we need to select the displayed elements. We're going to preview our equivalents, and we have this plane. So let's zoom in and make sure that's looking good. Okay, so we have all of these. And I think we have a good set to equivalents. So I'm going to go ahead and do that and return. Save again. Another thing you might want to do is you might want to skin this. Sometimes this is done in the automotive industry when you have three-dimensional elements. You create a two-dimensional mesh that's slightly offset from the three-dimensional geometry. And we can create that pretty easily if we go and show, for example, faces or edges. Let's see. We'll find the faces. We can turn our specimen off. And what we have here it looks like it's 3D, but these are actually two-dimensional elements that are in here. Let's mask some elements by window. That was a little weird. I think you should have selected all of those. Okay, there we go. And if we look in there, it's hollow. Okay, so that's something that we can do too. And depending on how we want to apply our boundary conditions to this, we may do a contact surface between these shells and the solid in the grip portion. That would be one way to apply that, and we can move this like it's the grip that goes around the specimen, or we might just select a bunch of nodes and then do a displacement on it. So we'll worry about how to apply our boundary conditions in the next segment when we look at Abacus. Alright, so make sure you turn these faces off. You can unmask it if you want. And make sure that your specimen is the only thing that's on the screen, and we're going to export this mesh as a solver deck. Standard 3D and export displayed. Okay, so that's real important. You can do custom or displayed, but displayed is what I usually like. And again, only display the elements that you want to see. So we'll create a file name. Click on the little folder icon. We'll put it in temp. And then hit export. Now, one last thing that we probably want to do is we want to identify some nodes where our extensometer is going to be, so we can get the relative displacement between that extensometer. So let's turn our lines back on. And I believe it was at this location and this location. We'll find out here in a second. Picked a node, wasn't quite the one I wanted. So if you right click, it'll make it disappear. So let's look at the Y distance, 76.2. Okay, that is right there in the middle. Okay. So if I select a node right here and a node right there, I want to find those node numbers, and then we can see where we're at. I'm going to do that on my own and won't record that, but I think this is good for another example of using Hypermesh to make something.